so we're right there. Wow, those lights are bright. Ready to go? Good afternoon, everyone. Can you all hear me? There you go. Thank you very much. My name's David Bader. I am the worldwide go-to-market lead for robotics, factory and warehouse automation on the AWS IoT team. Been with AWS about 3 or 4 years now, and we're excited to kind of share this message with you today, some of the projects that we've worked on specifically with Lockheed Martin around some robotics and IoT. So we're very excited about that.
I'm Tim Wilson. I'm an IoT enablement specialist with our worldwide public sector partner team. I work primarily right now with a lot of our defense manufacturers, and in this case, Lockheed Martin. So happy to be here and happy to partner with Dave to tell this story.
Exactly. So to start off, AWS for robotics is a bit different than than Amazon robotics. So what we do at AWS Robotics is we enable people to be able to leverage IoT as part of their robotics solution. In addition, we offer things like simulation and interoperability for commercial off-the-shelf robots. So there's a clear distinction between Amazon robotics and AWS robotics. So this opening video will give you kind of a small taste of some of the projects that we've worked with at AWS for robotics.
That's one small step for man, one giant leap for mankind.
Pretty exciting, right? I get chills every time I watch that video, and trust me, I watch it like 3 times a week, so it's pretty exciting. So what you saw in that video, the first robot that you saw is a company that we've partnered with. They're all partners, they're all companies that we work with. The first one is a company called Lunar Outpost. So in conjunction with the orbital reef discussion that you maybe just listened to, we're working with Lunar Outpost to actually put a robot on the moon this year. In fact, it's scheduled for launch later in 2023. That robot will be commanded and controlled through AWS RoboMaker and some of our other services that they use to build that. So we're very excited about that. There's some other robots that you saw there, warehouse robots, vacuum cleaning robots. All of those robots have been enabled in some way using AWS IoT services and some of our AWS for robotics capabilities. But today we're going to talk specifically about how we took a Spot robot from Boston Dynamics. We worked with Lockheed Martin and an IoT partner called Tulip, and we combined those together to be able to take the operational technology team along with the IT team and bring together a solution that could work in a very complex manufacturing environment like Lockheed Martin, missile fire and command. So they're building missiles in this factory, and it's a very, very complex application. So we'll talk a little bit about how we got there, and we talk about the Amazon working backwards process. We'll talk a little bit about how we identified use cases, and then Tim will talk more about the solutions and some of the architectures that we've developed around this. So the working backwards process at Amazon is really, really important. We take it seriously as one of our key elements when we engage with customers. And the idea is we listen, we try not to solution anything before we start, and we listen to what the customer is trying to accomplish and how they're trying to accomplish it, and then we build a mechanism to work backwards from that problem set and identify some of the key elements from which we could work. And that takes a couple of different methods. for us to do it. It could be simply sitting across from a table or on a video call, or in the case of this project with Lockheed Martin, we actually took advantage of a digital artist. And we had, in many conversations, we had a digital artist replicate some of the work that, some of the discussions that we were having, so that then we could use those digital representations of our conversations to work backwards and come up with a solution. So this is kind of what it looked like, right? Is this digital artist came up and said, look, let's not talk about the how, because we're going to come up with how we're going to fix this problem, but let's figure out why we're going to do it and then what the problem is first, right? So we came through and we worked with the leadership team at Lockheed Martin, and they came up with very specific points that were critical to their overall business. It's not just about implementing a robot. In fact, when they came to me and said, hey, Dave, you're the AWS robotics guy, we want a robot. Well, AWS really doesn't sell robots, right? We enable companies to use robots and to empower them to use IoT on their robots. So we worked backwards and we said, hey, it's got to be affordable, it's got to be relevant, right? There's geopolitical issues, so we have to understand where the robots come from, how they're built, those things. And then what do we want to do? We want to build a digital twin of our factory. We want to be able to move parts around in our factory. We want to be able to have just-in-time inventory delivery to our machine centers. And all of those things came out in this discussion with the leadership team. So then we start to think, how are we going to do this and what are we going to do? But if you look right in the center of this slide, it's all about more digital manufacturing. So many of you that are involved in manufacturing could probably relate to the fact that not every factory is fully digital. Here we are, 2023. We would think we'd be digital. Everybody be digital, but that's the process. So identifying that they want to become more digitally aware, and how we could do that using robots and other automation technology. So what are those outcome objectives from that first diagram? We discovered 3 pillars of that were critical to the overall solution. And these are not unique pillars. These are pillars that most customers want to achieve. But identifying by going from, hey, I want a robot, to I want to improve quality and I want to eliminate data silos and I want to fill out those automation blind spots, that's really what was important about that working backwards session. So then we said, okay, we've got a lot of things that we want to work on. These are all boiled into one big pot. And how do we, what are those actual transformation pieces? How are we going to action what we've just discovered? So we came up with 4 initiatives that were really important to this customer. And we decided we're just going to work on one, right? So at Amazon, at AWS, we think real big, and then we act small in the beginning, and then we work to the overall solution. So that's what we did here, right? We said we're just going to focus on the machining center manufacturing process in their building. So their overall problem set was, hey, we have machine tool breaks that happen 15 to 20 times a day. So a machine tool breaks in a machining center. The operator has to leave his workstation, walk to the tool room, identify what tool broke. Manually, the tool maker hands him a new tool or sets the new tool in the collet. He hands the tool back. He walks back to his station. 45 minutes to an hour for every tool break, 15 to 20 times a day. The math doesn't add up. They were losing productivity. The efficiency was gone. So we said, let's automate that process. So they had it's a perfect application for an AMR, a mobile robot, but their floor configuration was very not level. So we decided to use a spot robot. But the first thing, and you may all think that working with a company like Lockheed Martin or any large industrial company, security is pretty important, right? Understanding how the data gets through their system and into the cloud in a secure, reliable, and kind of a fast fashion. So what we did, and Tim and the team were super instrumental in building this industrial factory fabric. So that's a framework that they built inside of Lockheed Martin's networking system. So this is where we had to go to the IT team and say, hey, we're looking to fix your operations here, but we need IT help, right? We can't do it on our own. So we created this working group with the IT team, leadership team, and their overall group, and the operational technology guys and their team. And we said, let's build this industrial factory fabric, and then we can use AWS, some of the services that AWS offers that add to that security as well. And that's what we ended up. So we were able to standardize on the data formats, make this extensible across all of their manufacturing facilities. This particular picture is a gentleman building an F-35 fighter jet, but it works in the missile factory and everything. So when we look at it, we deployed the industrial factory fabric way back in 2021, and I honestly think that this is pretty aspirational to get us to in 24 to get us fully automated and data driven. I think it's going to be much longer than that. So the expectations here, what I'm trying to set is, this is not an overnight solution, right? This is something that's going to take some time, regardless of how slow or how fast you intend to use this. So right there in the middle of 22, we'll have this robotic delivery system up and running across the entire factory. So we've done the work already. We're good to go. We've got all the security together. We've got all of the purchasing together. Everything's working really well. But by 24, we'll have that rolled out across several plants and in different types of applications. So ultimately, this process and the solution that we came up here works not only for new factories, because believe it or not, Lockheed is building new factories right now for new operations, and they want to be able to start digital from the beginning. So we're using the same structure, this industrial factory fabric, to build that infrastructure so that they can then start to bring in machinery that's connectable and is already IoT enabled to be able to work with AWS and their industrial factory fabric. And it obviously, it works with brownfield factories as well as I just described. So this is where Tim takes over and talks a little bit more specifically about the application.
Thanks, Dave. So in this particular use case, Dave teed up is a machine shop within one of their Lockheed facilities. So they have several, big CNC machine workstations or lines. And we wanted to automate that tool replacement workflow where, we're talking about a paper process where that machinist breaks a tool, they write some notes on a tool cut list. They're walking that piece of paper to that center, that MDO right there, that center, what we call the tool crib, to get that replacement. They go through that process. Once again, they're doing more paper annotations, putting stickers on things, and then ultimately putting that fixed tool with that piece of paper out on a little cart, and that machine operator goes back 45 minutes later, picks up that tool, and then proceeds to go back to their work and start the machine process over again. And so with this particular use case, we identified what we call material drop-off locations, pickup locations, and then these digital workstations. So this will providing a application for a machine operator to request a new tool or tool replacement. And so we're rolling out applications to those digital workstations at each workstation at the CNC machine center. And then the MDO, that material drop-off or tool drop-off, will be at the tool crib. And so this is just kind of some conceptual drawings of what that looks like. So you have on the bottom left there is that machinist at a CNC machine with their screen. And so not only can we automate that flow, but on that upper right-hand side, we'll also be able to provide some of that digital signage on the shop floor so that the management can see, get leaderboards, get an idea of like the actual cycle times that the operators are going through and how efficient they are in their tool replacements. So to do the application deployment and development, we, as Dave mentioned, we engaged with a partner of ours called Tulip. And what they provide is a low to no code app building, deployment, and testing environment and service specifically for the manufacturing and industrial industries. And so think about work cells where a individual is doing a bunch of steps to build a widget, or in our case, where a machine operator needs to request tools and specify the exact the tool and the offset and everything for this particular fixture that they need. Instead of building and hand rolling custom applications that is very difficult, you have to have a development team, you have to have a way to deploy and publish those to an edge device at the work center. Tulip has that all as a service. So not only the web-based application development environment that is low and no code, so the OT team, they're not relying on the IT team to build out these applications. The OT team can actually build, develop, and evolve these applications over time. It also has the client software to run on the PC that's at the workstation, could be a mobile device, a tablet, kind of the full range of end devices that these applications can easily be published to is what Tulip brings to bear in this situation.
Can I jump in there real quick,
Yep.
Tim? So one of the key things with this, why we chose a partner to do this is when we did the working backwards and we did the discovery, we found out that Lockheed had more than 15 different software systems that fed into their manufacturing. Over 15 different software systems. Now I know if there's manufacturers in this room, you guys don't have that, right? You got it all streamlined. There's no overlap of software. So what we had to do in order to solve this problem was come up with a system that could connect all of those software systems together. And that's what Tulip really brought to the table.
So I mentioned before, we have both the industrial apps for the frontline operators, but then also the strong, robust analytics capabilities for the supervisors. And while the IFF that we were talking about before, that's pulling the machine data, pulling a lot of the metrics into the cloud to do the analysis, get visibility into the overall manufacturing process, what's nice about Tulip is that by pushing an application down to the shop floor, they can get the cycle times. Lockheed can start tracking the cycle times for a given process. So as as the workflow, the application workflow goes through, we're calculating when the request went in, when it was fulfilled, how long it took, and then they can take that data and start to pinpoint improvements and say, hey, on this particular machining line, we're seeing a lot of tool breakages in this particular area, and so they have that telemetry to then do improvements. Maybe adjust speeds and feeds, or maybe it's a different coding on a particular end mill that they can start adjusting, and so driving that efficiency because they'll actually have the visibility into that particular workflow. So that's on the application side. Now in the middle of this is that robot selection, and Dave mentioned we're dealing with a environment. This is a machine shop with narrow, kind of variable walk paths to the various drop-off and pickup locations, and then variability in the floor. And so that kind of drove the selection of Spot, but it also was, a more interesting robot, so kind of drove a lot of interest within Lockheed Martin to, as they kind of embarked on this robotics endeavor. So kind of driving some of that excitement and buy-in by a lot of the various constituents. But if folks are new to Spot, Spot can actually has a payload. We're talking around 14 kilos, and so that's what we're using, that payload capacity, as a way to basically Lockheed is printing out 3D printing a specific tool holder basket that goes on Spot's back, and he will securely hold these very expensive tool fixtures, but then can really navigate through these variable locations with full stereoscopic cameras in all sides of Spot, and deal with various pitch on the floor, etc. What's also important, kind of as Lockheed looks at the future, is kind of an adaptable platform, so that not only are they doing this kind of this material pickup and drop off use case, they can start to adapt that moving forward. So the Spot arm enables manipulation, but also has a camera, so it can do inspections. And so, some early ideas of, well, Spot's always walking around, why not do inspections while he's walking around? And then in the future, doing inspections as a part of a dedicated robot to do inspections throughout facilities or even within a particular production line.
So, and inspections could also mean like closed loop inspections, things like using machine learning to say, hey, is my fire extinguisher in place? Yes, it is. No, it's not. What do we do to mitigate that? Or even things like looking at analog gauges and using AWS services to be able to digitize that analog gauge and to tell them, hey, your steam line is too high, or your water level is low, or what have you, without having to change the infrastructure.
And that actually, Spot Core I/O is actually a compute module attachment that you can put on Spot to do that closed loop. You can run actually some of our software called Greengrass, which allows you to do that computation and data ingestion at the edge. Finally, the last part of this, so we have the application side, that's the user interface, the application that we're pushing to the end users, whether it's the tool crib or the machinist. Then we have the robot, that's our automation piece. But then the important part is that we need to connect all these data points together and actually do the command and control of Spot. And so this is where we built out over the last year or so with working with Lockheed, is a kind of comprehensive architecture for automation that can be used with Spot for this particular use case, but more importantly is adaptable and expandable to other robotics platforms and the multitude of other use cases that are possible with robotics. And so in the center here, we have our kind of core IoT analytics and command and control data pipeline. So at the center, we have kind of this industrial data lake. This is part of the existing infrastructure as part of the IFF that we worked with over the last 3 years with Lockheed to build out. That will also include these data pipelines and this kind of operational data store using our DynamoDB and our Neptune graph database. And then we're creating basically APIs, command and control APIs that the Tulip application will interact with. And so Tulip talks to these APIs, and so you'll say, we would need Spot to do a pickup in this particular location. That sends a request via the application through this API, and that gets sent down the IFF and ultimately to Spot, task Spot to go to a particular waypoint to do like a tool pickup. And so if we look at that particular piece, we have our two main services that are coming from our IoT set of services. Our IoT Core, which provides that command and control, what we call like a shadow. So this ability to have a desired state of a particular device. Say in the case of Spot, we say, Spot, we want you to go to waypoint, pickup location A. We update its shadow, and then that shadow gets synced down to the IFF to a compute gateway, essentially, that Lockheed is running, and that runs our Greengrass service as essentially a compute gateway's piece of software. So that shadow gets synced down to the Greengrass gateway, and then Greengrass has this component architecture that we have built a component that utilizes Boston Dynamics SDK to do the command and control. So that component gets a request to say, we want Spot to go to waypoint A, and then that command and control component hits the Spot endpoint, the API endpoint that is running on Spot via the SDK to command and control him across the particular machine shop floor. Yep. The other part to this is the integration with the existing software stack and services that Lockheed uses. Things like the MES, the PLM, the ERP systems. Those are all critical components to driving these automation workflows. You need to know work order IDs. You need to know that you need to have a tool database. You need to know your inventory and things like that coming out of your ERP. And so this architecture also has a kind of a way to reach back into those systems and pull the relevant data to drive this use case.
And I don't want to underestimate the video streaming, right? So yep. Kinesis Video Stream is another service that we have that enables us to be able to bring low latency video and store low latency video in the cloud. So for the inspection applications that we kind of alluded to, that's huge, right? Being able to bring real live video in and store it and be able to analyze it using other analytics tools is a very big, and it was a very big important part for Lockheed as well, because they didn't want to have to outfit their entire facility with vision systems for every application. So this mobile vision system is really one of the driving forces behind this. I think we got to.
We're just going to end it with a kind of this was an early demo conceptual project we did with Lockheed that really kicked off the development process. This was, using Spot in their facility to test out some of the mobility of doing tool or material pickup and drop off. And so this is just a video that explains that initial effort that kicked off this project. Yep.
Lockheed Martin Missiles and Fire Control operations team collaborated with Amazon Web Services to reimagine how we work and demonstrate how the Boston Dynamics Spot the Robot Dog can help us transform our Grand Prairie operations to generate products faster and easier. During the demonstration, Spot showed the team various interactions and scenarios to explore automation on the operations floor, like material delivery. Spot will benefit manufacturing operations by augmenting our existing workforce and supporting people's day-to-day monotonous tasking, allowing our employees to focus on the critical aspects of their roles, ensuring we are meeting customer needs and manufacturing quality products. AWS tools provide machine learning and Internet of Things capabilities that enable predictive ordering and direct Spot to inspection tasks to keep the facility running smoothly. Together with AWS, Lockheed Martin is revolutionizing our factories, tools, and processes to enhance production, answering our customers' needs, and delivering mission success.
Awesome. I think we have a couple of minutes left for questions. Yep. If anybody has any questions. Sure. I don't know if we have a microphone. Do we have a microphone? No? I'll just repeat it. Yep. There's a lot of low-code, no-code environments. There you go. Yeah. So there's a lot of no-code, low-code software around. Why did we choose Tulip? Honestly, I'm not even sure what the overall process, but Tim might be able to talk. But they're an AWS partner that is being used in many different applications already at AWS. But we did evaluate several others in this process.
Yeah, I think there's probably two main aspects. They are dedicated to manufacturing. They're US based and they run in our GovCloud region, which is a critical requirement
for Lockheed Martin, right?
Yeah.
Yeah. But we're not. That's not that's not an end game, right? The way that we've architected this is that any low-code, no-code kind of application can integrate very seamlessly with this.
And you see the architecture too with this, with the way that the robot is tasked to go to a particular location. Well, right now it's driven by the Tulip workflow. It can be automated as well. You could have insights coming from a machine that says like, I already see tool wear happening on this. We're detecting tool wear. Automatically go request a new tool replacement, and Spot will automatically go there. So you can have that. That's all built into the architecture.
Thank you for the question.
So also thank you for that really interesting insight. My question is, was it a big problem, especially if you have so many different CNC machines, different suppliers? Was it a big struggle to get, especially off the machines, the data out? How was there, especially that I think maybe that was Tulip's work to discuss with the different automation vendors? Can you give there some insights how especially with the OEMs or with the machine builders, how the talks on which level are they?
Yeah. So with the machine shop and the machine data, that work was laid down with the IFF over the last 3 years. They are, with that machine shop, they're pretty standardized, and for the protocol they standardized on MT Connect protocol. So that's rolled out, and so for the most part, that's not the limiting factor. Usually, they can get a new machine online very, very quickly. It's pretty standardized, the connectors for getting that data into the data lake.
But it was all the other software pieces that also had to connect that was really the challenge. Exactly.
It's this particular project has been a lot more on connecting is even like dealing with like paper processes and looking for all the different data sources and figuring out how to connect to them. Yeah.
Yes, sir.
Yeah, thanks for a great presentation, a very interesting case. I'm trying to understand the business case though, because it looks fancy. I mean, having a Spot running all over the place is of course pretty neat.
Yep.
But I feel to understand what the business case behind it is.
100%, great question, because that was where I was, right? I'm a robotics guy, and this guy's asking me to put robots in. And I'm like, we got to work backwards and figure out what that business case is. So if you look at it, and this was like one of those kind of light moments, where the light blows in your head. We were walking the facility, kind of just doing an initial assessment, and I noticed that there were literally 4 machine operators standing at the tool crib waiting for tools. They weren't waiting for tools; they were talking. They stopped to see their friends, and the machine was left untended. It wasn't that the machine was working and left untended, the machine was down and left untended. So what we were able to do is work backwards and say, if we can reduce the amount of machine downtime, then that's where the ROI is going to come from. And quite frankly, we did it in a couple of ways, and I think this is really important. It's a union shop in the first place. So automation, sometimes you have some hurdles to overcome with automation, but we went to the union and we went to the operators and said, look, we're going to try to help you make your job easier, make it better. We're not taking away anybody's jobs. And we kind of positioned it that way so that when we brought Spot the first time, everybody was involved. Everybody took ownership, and the operators felt like if they could be more efficient, then the company's going to be more efficient and their jobs will last longer. So there really is an ROI. It's still being proven out to see what levels there are, but we would never have ventured into this project without an ROI.
Yeah, and I'll reiterate an aspect. I was just talking about the paper processes. Yeah. Even just it as a forcing function to actually get all the systems in place for future robotics workloads is a great payoff. It was just as like a pure fact finding and integration forcing function. It's been a
over and above the material movement.
Yeah, above that, it's just like a overall exercising muscle has been a really good outcome.
Anybody else? Thank you very much. It was a pleasure. Thank you. You want water?